Yesterday afternoon, I posted a video for graphing using Google Spreadsheets, or the way I wrote it, Google Spreadsheets. Eventually I'll correct that spelling. So if you're having trouble with Excel, you have that as an alternative. At this point, I think there's like 5 different versions of Excel floating out there, and apparently I'm having difficulty with some of them. So, sorry about that. It's gotten more complicated than expected. But at least everyone, since I think Google Drive, Google Spreadsheets is going to be the same for everyone, at least. Those instructions, that video should work, at least until Google decides to change it. Any questions?
Well, I did have some difficulty with it, just only when it came to changing the values for the horizontal axis. I couldn't change it. I could do everything else but change the values for it. So it's still like 1 through 5 instead of the actual centimeters we did the drop height for.
Oh, it gave you said 1 through 5?
Yeah.
I believe that's because one of 2 things. One, the data that you put in there, you basically gave it only the bounce heights, and it doesn't know what those values are, so it just goes 1 through 5, or you're not doing a scatter plot. That's,
I'll show you in the axis.
yeah, that'll work quite well. I think that's an easy fix. We'll find out. Thank you for noticing that was an issue. I'd gotten graphs where they didn't bother, which throws the slope off, which throws all the analysis off. Other questions? Okay. We will be doing a lab today, and I've got those printed out. Oh, for the lab piece of the course entry assignment is due at the end of today. You need to have it submitted at least once by the end of today. For the class, that deadline is tomorrow at the end of the day. Some of you have not done it yet. And I think there was one that hadn't submitted. I saw the blue dot on my screen, which indicated that it had started but not submitted. So just make sure that, I guess the ones, I have the list of the ones who submitted for the class. I just did a quick glance at for the lab piece, but those are 2 different course entry assignments. The last thing we did was no doubt incredibly exciting. Just listing some scalar and vector quantities. Okay. Let's plunge into some chapter 2 stuff. After this, actually potentially before that, the chapter 2 master set, you should be able to handle some of the problems. Don't wait till we're done with chapter 2 before starting on that master set. Let's talk specifically about one particular type of vector quantity, force. Now, in physics, there's 2 major concepts that we would love to be able to teach you all at once. It's basically chapter 2 and chapter 3. Unfortunately, we can't do it all at once. So occasionally I will make references to things that we haven't covered yet, such as if I mentioned acceleration. Acceleration and force go hand in hand, but acceleration is chapter 3, force is chapter 2, and then when we get to chapter 4, it combines them. But I will make references to acceleration probably, and just because I can't feed, and that's the wrong word, we can't cover both of those topics simultaneously. All right, so let's start out with something simple. What is a force?
A push or a pull.
There we go, yep. You know what the unhelpful definition is? That's probably the best working definition that I've come across. There is another one that an influence that might cause acceleration, which to me is a completely useless formula or definition. It is a vector quantity, thus the symbol, the vector symbol over it. And when we're starting out, for most of the course, there's only a set number of forces that we're going to deal with. And so I'm going to sort of go down the list of the forces that we will deal with. Friction. Tension. Other, and I'll explain what other is in a moment. Weight. And normal. I could not come up with a single word. The best I could come up with F-town, that's the memory trick. So let's start out with probably the one that most of us are familiar with, weight. Now weight does have a specific meaning. Actually, Hewitt defines weight one way in one part of the book and then later changes his definition. Different textbooks do it slightly differently. Some textbooks do weight as, in essence, if you're standing on a scale, what does the scale read? That other will define weight as the gravitational pull. So that is the way that I go on it. So weight is the gravitational pull. Between and with small in quotation marks there, small object near a large object. All right, the reason why I have small and large in there is that an elephant would be considered a small object. Empire State Building is a small object. Large objects, we're talking planet, moon, something of that nature. It's called weight if you are near it. So I am near the Earth, so if I wanted to figure out my weight's probably somewhere around 220 at the moment, which is a really bad way of wording it. What's wrong with my saying my weight is 220? And this is not a health issue, this is a wording issue.
220 what?
Yes, exactly. 220 pounds. Now, weight doesn't have to be in pounds, it's a force, so it's any unit of force. So pounds is our customary unit. However, in metric, since we'll be dealing with metric, the units of force are the Newton, is the Newton. Now, if I want to represent unit and put it in the square brackets, and this is just saying that the units of force is the Newton. If I put, like I say, Newton, pound, ounce, ton. If I wanted specifically to talk about the metric system that we'll be working with, I could also write this as, put a little SI down there for Standard International. Sorry, French, Standard International, or International Standard is the Newton. Anyone want to take a wild guess who's being named, for whom this was named? Who's being honored? I think somebody's just said it.
Isaac John Newton.
Sorry, say again?
Is it Isaac John Newton or something like that?
I don't know about the middle name, Isaac Newton.
Oh.
Sometimes Sir is thrown in front, Sir Isaac Newton, if you're looking for 3 words. I don't know if I've ever seen a middle name for him. Anyway, it's the Newton. Now, Newton is what's called a derived unit. And a Newton, introduce a new symbol here. When you see the three lines like that, this means it is true by definition. It's not just that they're equal. This is true because the powers that be sat down and they said, we are going to define a Newton this way. So this is equal by definition. And it seems to be a little bit archaic. Occasionally, you'll also see equal sign with a triangle over it. I don't see that as often, but that is equal to a kilogram times meter per second squared. So Newton and a kilogram meter per second squared are the same thing. But if you're dealing with all international standard units, if it's a force, units will be newtons. All right, so that is weight, and I need space now, so I'm going to erase this bit. All right, so a requirement for weight is a small object near a large object. Actually, large doesn't feel quite right. Huge, what we do is huge. And again, huge object or large object, we're talking about planets, moons, something of that size. Now, this is what we're going to be dealing with until we get to chapter 9. I think it's chapter 9 or 10. As I mentioned, it's a gravitational pull. There is a more generalized equation that's different than weight in the fact that if I'm talking about the Earth and the Sun, there's a gravitational pull there. That's why the Earth goes around the Sun. So, but it's not weight because we're not dealing with an object. It's not near enough to the Sun. So there's a more general, I just want to squeeze in here, sort of generalized gravitational, which we'll get to later on. So generalized gravitational force. And that just requires two masses. There's a gravitational force between me and each of you, between me and the ceiling. It's not much. I can walk away, or you can walk away. The pull is not so much that we can't escape it, but it's still there. Now, the symbol I use for weight is a lowercase w. Usually you put a little flare off to the side there, a little serif, just to differentiate it from a capital W. And for the generalized gravitational force, the symbol I use is an F sub G. Little subscript G for gravitational. And the requirement for the generalized is just two masses. So gravitational pull between your left hand and your right hand. Again, not particularly powerful, and that's why we'll ignore it for most of the course. As we will talk about in more detail in chapter 5, forces come in pairs. And the forces in the pair for weight will always point towards each other. Slightly more detail, we'll get into it potentially not today, but on Tuesday, that the forces in the pair will point towards each other. Each of those forces in the pair will act on a different object. So right now, the Earth is pulling down on me, so the force acting on me is down, but I'm also pulling up on the Earth. I'm pulling up on the Earth with about 220 pounds of force. Because they're so massive, it's not noticed. And then, I guess this is forces in the pair, direction of forces in the pair, and then forces, direction of forces with respect to the objects. It points toward center of mass of other object. So the force acting on me, the gravitational force, my weight acting on me is pointing towards the center of mass of the Earth, which is about the center of the Earth. All right, one force down. It's getting exciting. I know it. You can read your minds. Any questions at this point? I should have done it because I was reading your minds. All right. Normal force. Anyone know what normal means? It's a math term.
Constant?
Pardon?
Like constant or something?
Not constant. I think constant's the only term I've heard for constant, really. You're thinking typical or usual, sort of that sense of normal? Yeah, no, the math people, they didn't do it that way. How dare they? Sometimes it means average, which is as close as math gets to that. Perpendicular, it means perpendicular. Why they come up with the word normal, not a clue, but it does mean perpendicular. And again, I think like yesterday, or whatever it was, I don't like writing out the word perpendicular. I think that was miswritten. So I just put the symbol perpendicular. So you might be able to guess that the direction of the forces will be perpendicular to something, and they will be. What's required though, the requirement is I need two objects touching. There's a normal force between my feet and the ground, or the carpet. There's not a normal force between me and anyone else in here. The symbol that I use for normal force will make pretty much no sense. And even after I explain it, it still might not make sense. Capital Y. And I use a capital Y because, one, I don't want to use a capital N because capital N I'm reserving for Newton, and otherwise I'd end up with an equation of, if I use capital N for normal, then I could have N is equal to 3N, and those N's mean something different. And there's enough confusing stuff in physics as it is, so I don't want to do that. So normal force, I use a capital Y because my high school physics textbook used a capital Y for normal force. That's the reason. Some students will use, instead of doing that, we'll do F with a lowercase n here, just as a subscript, if that makes more sense to you. Generally, what we're leading towards is the force diagram. There's loads of videos on how to do those through Blackboard. And some students, when they do the complex force diagram problem on the first test, they'll use F sub n. Some will use a capital N, and I try to go with the spirit of what's being done in that problem. But try not to use capital N for normal. All right. The direction of the pair of forces, because again, forces come in pairs, is they will always oppose each other. Right now, the floor is pushing up on me. I'm pushing down on the floor. And the direction of the forces, it's perpendicular to the surfaces of contact. So if I lean against So I'm leaning like this, the normal force acting on my feet is still upwards. It's not at an angle. Questions to hear? All right, tension. Tension, the requirement for tension to exist is there needs to be a tight or taut rope, chain, string, whatever it happens to be. It is a pulling force, and as we mentioned before, it comes in pairs, and the tension, the pair of forces is always towards each other. And the direction with respect to the object, with respect to the rope or chain or whatever, is that it is parallel or anti-parallel to the rope, chain, whatever you have using. And in some sense, tension and normal are slightly opposite. Tension is when there's pulling going on, and normal is when there's pushing going on. And I think one of the videos that I've posted is questioning whether tension really exists or not, and explaining what we throw into tension. But it's typically when we don't really know how two objects are connected to each other, we would use tension. Friction requirement. Two objects with desired relative motion parallel to surfaces of contact. So there's two things implied there. One is that there need to be surfaces of contact. They have to touch. You will not have friction